Current smart contracts automate transactions with total transparency. While efficient, this architecture provides no native mechanism to shield the institutional intelligence driving those transactions. This creates a structural conflict. The public, immutable ledger that makes decentralized finance trustless also exposes the proprietary workflows that institutions rely on for competitive advantage. Under the current model, risk evaluation models and collateral strategies must be coded directly into the public Ethereum virtual machine to be executed. This forces lending policies, portfolio allocation methodologies, and internal approval rules into the open, where they can be tracked by any observer. Every lifecycle decision and operational state transition becomes a matter of public record, allowing external parties to monitor an institution's internal decision-making in real time. Competitors can analyze these public data streams to extract specific parameters, like liquidation thresholds or risk scores, effectively reverse engineering an institution's investment strategy. Market participants can use this visibility to anticipate and exploit institutional moves, such as front-running predictable liquidations or identifying specific risk tolerances. While the underlying tokens are cryptographically secure, the business lifecycle governing those assets is exposed. The intelligence behind the asset is effectively unshielded. This highlights the core requirement for institutional finance. Transparency is necessary for settlement, but privacy is required for strategy. NoxGuard addresses this by providing a developer toolkit for implementing programmable privacy within standard Solidity smart contracts. The system is designed to integrate with existing protocols. Developers can add confidential layers to the applications they already use without redesigning the core architecture. Real-world adoption depends on this ability to protect proprietary logic. Institutions can only migrate to decentralized infrastructure when their business intelligence is as secure as the assets themselves. To bridge this gap, developers need a way to execute confidential policies on a public ledger while maintaining the ability for those contracts to interact with the wider DeFi ecosystem. The NoxGuard architecture achieves this through a multi-layered stack. It begins with an established protocol, such as Aave, which serves as the base layer for lending operations. This base protocol remains unchanged, performing its standard functions like accepting collateral or managing asset withdrawals. NoxGuard sits directly below the protocol as a middleware layer. Its primary role is to organize and manage the confidential business lifecycle. This layer includes the business rules engine, where proprietary institutional policies are defined and updated without being revealed to the public network. The state and lifecycle manager tracks the progression of a transaction through its various stages, maintaining an internal record of the business flow. In the rights and policy evaluator, specific user rights and transaction conditions are weighed against the institution's confidential rules. The transition controller then acts as the final gate, permitting or blocking state changes on-chain based on these off-chain evaluations. While NoxGuard provides the programming model, it delegates the heavy lifting of confidential execution to the Nox runtime. Nox performs these evaluations within a hardware-isolated trusted execution environment, specifically using Intel TDX technology. This environment generates a cryptographic attestation. This proof confirms that the logic was executed exactly as intended, without exposing the underlying data or code. This attestation is then submitted to the Ethereum settlement layer at the base of the stack. Ethereum serves as the final recording layer, documenting the state transition while the confidential details of the policy evaluation remain hidden. This is delivered as a developer toolkit, providing SDKs and hard hat plugins so Solidity engineers can implement these patterns into their existing workflows. By decoupling the logic evaluation from the final settlement, NoxGuard allows for complex, private business rules to coexist with public, composable protocols. We can see this in action by following a single transaction through the lifecycle of a collateralized loan. Looking at the workflow on the diagram, the process starts with the user pledging collateral to the smart contract. The assets are locked on the public chain, but the valuation and risk weighting of those assets are calculated privately within NoxGuard. Next, the system performs a risk and policy evaluation, running the user's data against the institution's proprietary models. This step is entirely shielded. The calculations happen inside the Nox TEE, keeping the risk scoring hidden from the public. Once the conditions are satisfied, the TEE produces the necessary attestation for the next step. This proof triggers the on-chain loan approval. The smart contract authorizes the borrow action based on the verified off-chain result. To the public ledger, only the approval and the proof are visible. The internal logic used to reach that decision remains opaque. During the term of the loan, the system continuously monitors the position against the institution's internal rules. Because these monitoring thresholds are private, market participants cannot see the exact point at which a liquidation might be triggered. When the user repays the loan, a final private evaluation confirms the debt has been settled correctly. Finally, the system releases the collateral or initiates a liquidation. This last state transition is recorded on-chain, completing the lifecycle. The system works through a clear division of responsibility. Aave handles the lending, NoxGuard organizes the lifecycle, Nox executes the private logic, and Ethereum records the result. This architecture transforms programmable privacy from a theoretical concept into a functional tool for Solidity developers. It removes the choice between public security and operational confidentiality, allowing both to exist within the same application. While lending is the initial use case, this middleware model is designed to support any financial primitive on the EVM. This architecture can be applied to diverse institutional sectors. Insurance protocols can use this model to manage claims processing and payout logic without revealing their proprietary actuarial data. Platforms for real-world assets can perform private KYC and compliance checks off-chain while maintaining tokenized settlement on-chain. This framework also supports confidential payroll systems and the optimization of institutional fund portfolios. NoxGuard provides a set of reusable patterns that allow institutions to move their existing business models onto decentralized networks securely. The shift toward on-chain finance requires a clear separation between public verification and private business strategy. This architecture makes that separation possible, allowing the public ledger to handle the finality of settlement while a private environment protects the strategy behind it.